That means you're asking A is a point which has XYZ.
Yes, sir.
That is 3D geometry, correct?
Yes, sir.
Very good. So whenever we have the three coordinates, I mean, what is your doubt? Me doubt ఏంటంటే ఇక్కడ slope apply కాదు. First point. Area of the triangle could apply కాదు. Area of the triangle formula లో x1, x2, x3, y1, y2, y3 మాత్రమే ఉన్నాయి. సార్ z కూడా వచ్చింది కదా ఇక్కడ ఎలా చేస్తామంటున్నారు మీరు?
Sir,
I have given
is equal to 0.
yes please.
Can we do determinant is equal to 0?
Determinant means x1, y1, z1, x2, y2, z2, x3, y3, z3. That is what you are telling.
Yes, sir.
In 3D geometry, directly we have the formula. మీకు ఐపీలో కూడా 2 marks కి ఇంపార్టెంట్ క్వశ్చన్ అది. షో ద గివెన్ పాయింట్స్ ఆర్ కొలినియర్ బై. నేను నిన్న కూడా మీకు ఒక పాయింట్ ఫస్ట్ పాయింట్ చెప్పి ఉన్నాను అనుకున్నా. యా, సో ఐ హావ్ గివెన్ ఎస్టర్డే ఇన్ ద ప్రీవియస్ క్లాస్. దిస్ ఈస్ one important point whenever we have the 3D geometry concept, that is AB plus BC is equal to AC or AC plus BC is equal to AB. Sum of the two sides is equal to the third side and a concept of chapter. Unda ikkada first point. Is it visible to you? All of you, collinear points, first point. Got it? Can we find the distance formula even for 3D also? X2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Clear? Ashifa.
Sir.
Is it clear, Nana? Ashifa?
Yes, sir. Clear, sir.
Right. In 3D geometry, I'll try to discuss those questions also. Okay. In 2D geometry, better to go for slope concept. And this is only the formula we are using in 3D geometry. At that time, I can discuss this formula, no problem. Very good question. As I said, just today, and most of you people are asking, sir, let's discuss with the centers of the triangle. Because will creates a problem for us always. Yes, this concept will creates a problem for us always. Yeah. So here 5 types of the centers are there, but most frequently used concepts are only 4. That is the first point. Let's discuss with the centroid. This is the first point. Point number 1 to be noted. Next, orthocenter. Next, circumcenter. Fourth one is incenter. But if you want to discuss with these points, that is centroid, orthocenter, circumcenter, and incenter, we require their first column elements. What are those? Median, altitude, perpendicular bisector, angle bisector. These are the 4 definitions what we require. Right? So if you want to define all the centers, the 4th center is also there, but it is not useful for us. That is X center. I'll give the definition, even formula also, but that concept is not useful for us anywhere in EAMCET or mains examinations. But anyhow, we'll try to discuss the definition as well as the formulas of X center also. What is the first pointer? That is the median. Yes, it has to give the vertices ABC for all the triangles. ABC will be given to you, and here D will be there. Next here ABC. Next it should be D. I have to fill the diagram. ABC. Yes. Clear? These are the 4 points I want to discuss today, and corresponding the properties are also there. Most of you people are aware of the properties of the median, I mean the centroid and orthocenter, circumcenter, and even the relation between these centers also. Right? So as I said, first we need to discuss with their definitions. What are the definitions of median? next altitude, next perpendicular bisector and angle bisector. I'll try to discuss one by one. Anyone can define what is mean by the median? Anyone? You know the answer? Simply raise your hands, or you can unmute yourself and you can talk. Median. You have to participate yourself. That is important for us. Middlemost value. That's not. I'm not asking for statistical data. That's mean median mode as we studied in.
సార్ తెలుగులో చెప్పనా సార్?
చెప్పండి పర్లేదు.
సార్ ఒక వర్టెక్స్ లో నుంచి వేరే దాని ఆపోజిట్ సైడ్ ని ఎగ్జాక్ట్ గా హాఫ్ గా డివైడ్ చేయటం సార్.
Very good. You are absolutely correct. What he said, a line drawn from the vertex and which passes through the midpoint of the opposite side. The median is the definition. What he said, Sai said, is absolutely correct. Right? A line drawn from the vertex. Line drawn from the vertex. From vertex. We are taking from vertex. ఒక వర్టెక్స్ నుంచి మీరు ఒక లైన్ ని డ్రా చేశారు, and which passes through midpoint of the opposite side. Midpoint of opposite side. Midpoint of opposite side. Very good. Opposite side. Yeah. So as I have shown in the table, even the diagram's second table is also there. So both the slides will be useful for us how to take the diagram of the median. The median is a line which can be drawn from the vertex which passes through the midpoint. And here, if you want, you can take the median as the midpoint. D is the midpoint of the opposite side, that is BC. Clearly, he has given two lines are visible. మీరు ఫస్ట్ స్లైడ్ లో ఇక్కడ ఒక్కసారి అబ్జర్వ్ చేయండి, టూ లైన్స్ ఇక్కడ కనిపిస్తుంది, మీన్స్ BD is equal to DC. So this AD line dividing your line segment BC exactly into two equal parts. Very good. And its point of concurrency, we can call it as a centroid. Correct? What is that? The point of concurrency of the medians. అటువంటి మీడియన్స్ యొక్క కన్కరెన్సీ. కన్కరెన్సీ మీన్స్ the lines, three or more lines are passes through the same points. We can call it as a point of concurrency, and the lines are called the concurrent lines. I'll repeat again. A line which can be drawn from the vertex which passes through midpoint of opposite side. Which passes through the midpoint of the opposite side. Very good. It is absolutely correct. So here I am taking ABC is a triangle, and we can take a line that can be drawn from the vertex. Here I am taking the vertex, passes through the midpoint of the opposite side. Their point of concurrency is called the median. Their point of concurrency, we can call it as a centroid. Now I can define the centroid. Centroid. The point of concurrency of medians. The point of concurrency of medians. Concurrency of medians. The point of concurrency of medians, and it is denoted by G. Generally, it is denoted by G. You are observing this is a D, and this is a E, and it is a F. So one important property to be noted in this centroid always. So whenever we have the centroid, what important property point to be noted? The first point to be noted is centroid divides each median. Any idea, please? Centroid divides each median.
The ratio 2:1.
Very good. In the ratio 2:1. This is one of the most important concept. Median in the ratio 2:1. In the ratio 2:1. Sir, for each median, I mean, this is 2:1. Yes, it is 2:1. Sir, if I want to discuss with another median, yes, it is also dividing in the ratio 2:1. What about B? B is also dividing in the ratio 2:1. Centroid dividing each median in the ratio 2:1. This is one of the most important point to be noted. The second point is, suppose if you are taking the centroid of the triangle, point number 2, the centroid is given to you. The centroid of the triangle is given to you. This is A vertex, B vertex, C vertex, and this is G. I'm going to take the areas, the corresponding areas of AGB, BGC, AGC will be equal for the centroid. Right? So whenever centroid is given, the centroid of the triangle ABC will be given to you. Then the area of AGB is equal to area of BGC is equal to the area of AGC is equal to 1/3 of the area of the triangle, because it is dividing the total area into 3 equal parts. 1/3 of the area of triangle ABC. Hope you can understand this point. The total area will be distributed as 3 parts: AGB, BGC, and AGC. So it is 1/3 of the total area. Now, point number 3. It is also one important point to be noted. Point number 3. I'll try to send the notes. You can copy the slides. Okay. So these are the things. Just you have to remember in a single table that you can discuss all the 4 points what I need to discuss today. Okay. So now here clearly we can discuss each and every point in that concept. And point number 3 to be noted is, this is important for us. Whenever the midpoints of a triangle ABC is given, midpoints, that is medians are given, midpoints of the sides are given. What are the midpoints of the sides? If I'm observing DEF, right? So let's see the next figure. Yeah. So if I'll take the triangle, like this, yeah, ABC will be given to you. Next, this is DEF, and if I'm observing the area of one triangle AFE, next FBD, next EDC, next FED is also there. How many areas are there? 1, 2, 3, total 4. Here, see here, 1, 2, 3, and then 4. The corresponding areas are equal. Whenever the midpoints are given, if DEF are the midpoints of the sides, if D, E, F are midpoints of the sides, so that everyone will understand this concept. Just we are revising once, that's it. Midpoints of the sides of triangle ABC, then the corresponding areas are equal. Area of the triangle, first one, AFE, is equal to area of the triangle FBD is equal to area of the triangle, that is DCE. Next, area of the triangle, first one, AFE, next one FDEB, next one EDC, and the next one, the middle part is there, the fourth one, FDE. Triangle FDE. As you said, this is equal to, is it 1/4 of the triangle ABC? So we can take it as 1/4 times of the area of the triangle ABC. Right? And the fourth point, that already we know that related to this fourth point, that is the formula just I'm writing. Right? So even length of the median is also there. We are finding the length of the median through A, length of the median through B, length of the median through C. These are all the points we can use even in 3D geometry also. We can make use of this concept in 3D geometry, right? You have to remember that concept in 3D geometry. That is the length of the median through A, the length of the median through B, the length of the median through C. Okay, yes, I'll try to add that point also. Just make a note of this for finding the length of the median when centroid is given. Let's have the fourth point, that is the formula. The centroid of the triangle ABC. Whenever if you are having any doubts while class is going on, you can raise your hands and you can discuss your doubts, please, no problem. Ask your doubts. So centroid of triangle ABC, whose vertices are given to you, whose vertices are, A will be given x1, y1, B is x2, y2, C is x3, y3. Is g of x comma y. And even for 3D geometry, you can add one more variable, x, y, z. That is the thing we are going to add. So x1 plus x2 plus x3 divided by 3, even for 2D and 3D also. Next, y1 plus y2 plus y3 divided by 3. This is also same for 2D or 3D. But 3D geometry, one more variable will be added. That is for Z1, Z2, Z3. Z1 plus Z2 plus Z3 by 3. It is just 2D. You will get only two coordinates, X and Y. This is the well-known formula. So no problem related to this. So I have to add one more point. That is the length of the altitude through A, through B, through C. Just we can make a note of that point also. Right? So this is the fifth point just I have added. Make a note of all the 5 points, please. Already we are aware of these points. Once just we are revising all the points. That's it.
అక్క ప్లీజ్ అక్క ప్లీజ్ అక్క నాకు మంచి ఇంప్రెషన్.
Clear, please? Can I move to the next point? Because this is an important concept. So we don't want to discuss, more than this. That's enough for us for centroid. This is one important concept. Out of the remaining centers, this takes an important role. Is it completed?
Yes, sir.
Till 5 points. I think the first point is not visible to you. Just a centroid divides each median in the ratio 2:1. This is the properties of your centroid number. We'll go for the orthocenter. Next point. All centers need to complete today. Next, point number 2. Second point. Second center. What is that? It is orthocenter. orthocenter. So as you said, it is the point of concurrency of perpendicular bisectors or altitudes. There is a lot of confusion always. The students, whenever I'm asking orthocenter, they will write circumcenter. They will do circumcenter concept. Whenever we are asking circumcenter, they will write orthocenter. Always will create some problem, right? So orthocenter, circumcenter means you have to remember some circle center. Circumcenter means it is a circle center. It's a simple thing. Okay. So what is meant by an orthocenter? We require an altitude. First, we require an altitude. First, I can define an altitude, that is a line drawn from the vertex which is perpendicular to the opposite side. A line drawn from vertex and which is perpendicular to opposite side, which is perpendicular to opposite side. So generally we are taking the triangle of ABC, opposite side is BC, that means vertex to opposite side. And here orthocenter means it is denoted by O, the point of concurrency of altitudes. Got it? That is a simple concept have to be remember, as I have shown the corresponding figures in about 2 slides. But can we have any property for this? Just we have 1 or 2 properties for this concept. After discussion of circumcenter and incenter, I'll try to discuss with the properties also. Right? Let's have the next one. That is third one. Property number 3. That is circumcenter. So first we require a perpendicular bisector. This will create a problem for us. Perpendicular next to bisector. Perpendicular bisector. So perpendicular means a line which made 90 degrees with an opposite side. Bisector means it is dividing into 2 equal parts. Perpendicular bisector means a line which is perpendicular to the side and passes through the midpoint of that side. Here 2 things are happened. One is perpendicular. Another one is midpoint, passes through midpoint, and which is also perpendicular to the same side. And here I'm not discussing the vertex. Remember that point. That line is not necessary to take from the vertex. That line I'm not taking from the vertex. Just only one thing is what? The line which is perpendicular to the side and passes through the midpoint F, and which is also perpendicular. Similarly, I can take the line. I can take the line from this side also. Let us take the line from this side also, right? They perpendicular to that side and passes through the midpoint, and it is F. And it is called what? Circumcenter, and it is denoted by S. Their point of concurrency of perpendicular bisectors. Point of concurrency of perpendicular bisectors. Point of concurrency of perpendicular bisectors. Called what? Circumcenter. It is denoted by S. Right? Now I can have some relation for orthocenter and circumcenter. Now directly he will not ask orthocenter and circumcenter. In competitive examinations, whenever he is asking orthocenter and circumcenter, something is behind that particular question, because we cannot do that long process what we have done in first year. Circumcenter means just we can take SA is equal to SB is equal to SC. I mean, we are taking the circle, and after that we can take SA, SB, SC. That process is not necessary here. So something is something is there behind this process of doing the circumcenter. That is SA, SB, SC. I'm taking ABC here. Here it should be S. The process is not necessary to do. Whenever he is asking circumcenter concept or orthocenter concept, that's we can make use of the properties. Let us have one of the most important point. This is also important for a right angled triangle. For a right angled triangle. If I'm taking a right angled triangle, then let us see, the circumcenter is the midpoint of the hypotenuse. The circumcenter is the midpoint of the hypotenuse, ABC, because which acting as a diameter of the circle. So this acting as a diameter of the circle. Which acting as a diameter of the circle. Got it? AC is a diameter means, what is the center? Center means the midpoint of the hypotenuse. For a right angled triangle, first one, circumcenter is midpoint of the hypotenuse. Circumcenter is what? Midpoint of the hypotenuse. Midpoint of hypotenuse. So what is here hypotenuse? That is AC. We can write S is equal to A plus C by 2. The second point, what is meant by an orthocenter? Orthocenter is the vertex where the triangle formed a right angle. The vertex which is at right angle. Which is at right angle, which has 90 degrees, what we can say, right angle. So simply, I mean, directly we can find out, we can observe that. So vertex B is the orthocenter, and midpoint of hypotenuse, that is AC, will be the circumcenter. So these are the two important points to be noted in this concept, circumcenter and orthocenter. Next, point number 3, third point. This is one of the most important topic for an equilateral triangle or centroid. First, I can discuss this. Centroid G divides orthocenter O and circumcenter, orthocenter and circumcenter, yes, in the ratio. In which ratio, guys? In the ratio, any idea? This is important property. Already everyone will remember this property. Centroid divides orthocenter and circumcenter in the ratio. In which ratio? Aisha, Mahesh, Sai, Anvesh, okay. Any other answer, please? Okay.
1:2, sir.
Okay. So remember, just one thing that you have to remember, the same ratio what we have done for centroid, 2:1. It is dividing in the ratio 2:1. Same thing how we people just centroid dividing, same ratio. It is dividing in the ratio 2:1. So from this what we can say, this is one important point to be noted, the relation between the orthocenter, circumcenter and incenter, orthocenter, centroid and circumcenter, that is G is equal to 2 times mx2 plus nx1 divided by m plus n. That means 2s 1 into O, orthocenter, divided by 3. So from this what we can write here, 3 times of G is equal to 2s plus O. This is the relation you have to remember. Nana, whenever he is asking orthocenter, suppose orthocenter that he is asking, you can write 3G minus 2s. Suppose he is asking orthocenter, what is orthocenter? How we can find out? 3G minus 2s. In G, centroid, denominator 3 will be there. The 3 and outside 3 will get cancelled. So this is one important relation to be remembered. So always your centroid G divides orthocenter, circumcenter in the ratio 2:1. And the relation has to be remembered as 3G is equal to 2s plus O. The last one center is there, that is in center. So any doubts regarding to the first 3, please? Median, corresponding centroid, altitude, corresponding orthocenter, perpendicular bisector, very good, perpendicular bisector, it's a circumcenter. Very good, guys. Just we'll go for the last point, that is in center, which is useful for us. Point number 4. Fourth point to be noted, that is in center. In center. So I have sent all the synopsis, all the concepts we have shared, I think so. The material will be shared to you people in your groups. Yes, please, you can ask.
సో ఒకవేళ సర్క్యూట్ సెంటర్ ఆర్థో సెంటర్ ఇవ్వకపోతే సెంట్రాయిడ్ ఆర్థో సెంటర్ ఎలా కనుక్కోవాలి సార్?
ఒకవేళ సర్కమ్ సెంటర్
సెంట్రాయిడ్ ఇవ్వకపోతే ఆర్థో సెంటర్ ఎలా కనుక్కోవాలి?
ఆర్థో సెంటర్ ప్రాసెస్ మీకు లెంతీ ప్రాసెస్, బట్ కాంపిటేటివ్ లో మనకి కాంపిటేటివ్ ఎగ్జామ్స్ లో మీకు రైట్ యాంగిల్ ట్రయాంగిల్ మాత్రమే ఇస్తారు, గుర్తు పెట్టుకోండి.
స్లోప్
వెనెవర్, ఎస్ ప్లీజ్, దట్ ప్రాసెస్ హీ విల్ నాట్ ఆస్క్. దట్ ఈస్ వాట్ ఐఎమ్ టెల్లింగ్. అంత లెంతీ ప్రాసెస్ మనకి 1 minute లో క్వశ్చన్ చేయడానికి అడగడు అంటున్నా నేను. మీకు అడిగే క్వశ్చన్స్ ఎలా ఉంటాయంటే, రిలేషన్ బిట్వీన్ ఆర్థో సెంటర్, సర్కమ్ సెంటర్, సెంట్రాయిడ్, ఆర్ he will ask the question related to the right angle triangle. ఒక పాయింట్ చెప్పాను మీకు. సెకండ్ పాయింట్, రైట్ యాంగిల్ ట్రయాంగిల్ అవుతే ఆర్థో సెంటర్ ఏమవుతుంది మీకు, ద వర్టెక్స్ వేర్ ఇట్ ఫార్మ్స్ ద రైట్ యాంగిల్ ఈస్ కాల్డ్ the ortho center. Okay, now anta lengthy process manaku adagadu nanna. What we have done in first year, ఒక ట్రయాంగిల్ ఇస్తాడు మీకు. ఆ ట్రయాంగిల్ నుంచి ఫస్ట్ ఇక్కడ ఏబిసి వర్టిసెస్ ఇచ్చి ఉంటాడు. హీ విల్ గివ్ ద వర్టిసెస్ ఆఫ్ ద ట్రయాంగిల్. యూ కెన్ ఫైండ్ ఫస్ట్ ఏం చేయాలి, మీరు ఇక్కడ బీసీ యొక్క స్లోప్ ఫైండ్ అవుట్ చేయాలి. నెక్స్ట్ ఏడి స్లోప్ విల్ బి -1/m. ఎస్, స్లోప్ ఆఫ్ దిస్ విల్ బి m. The line passing through A and perpendicular to BC means y minus y1 is equal to -1/m into x minus x1. First, we are finding altitude AD and one more altitude BE. Solve these two lines, you will get the center. The process is never asked for EAMCET or any competitive examinations. Remember, hope you can understand my point, guys, because in 1 minute we cannot do all the process. Okay, so he will ask the questions logically. Entirely depends upon the right angle triangle or the relation between the centers. Clear?
Yes, sir.
I'll go for the next. You don't bother, but we'll try to discuss the previous questions also after completion of your introduction. I'll try to discuss previous questions chapter wise. No problem, right? Including recent years papers also. So in center means first we need to discuss with angular bisector. Angle bisector. Angle bisector. Angle bisector means a line which can be divided an angle at that particular vertex into two parts, into two equal parts, right? The synopsis related to this concept prerequisites. So we'll try to share in your groups. Better to take the Xerox or printouts for that particular 3 pages will be given to you. So the set of points are the set of all points joining are equidistant from the intersecting lines is called the angular bisector. The simple statement what I have given to you, no? So suppose this is your triangle and angle A will be there, an angle B and angle C, right? So here a line which is dividing an angle A into two equal parts. Similarly, for angle B, two equal parts. For angle C, two equal parts. Their point of concurrency is called an incenter. An incenter. Got it? And for an incenter, the triangle is located inside of the, the circle is located inside of the triangle. Right? So this is, the rest of the part will be not necessary for us. The angle bisector is a line which bisects the angle. Which bisects the angle. The line which bisects the angle. Bisects the angle. So what is meant by incenter? The point of concurrency of internal angular bisectors. The point of concurrency of internal angular bisectors. Internal angular bisectors. Angular bisectors. Sir, you are specifying internal angular bisectors. So what is meant by an external angular bisector? Can we have external angles also? Yes, we have an external angles also. That center is called an excenter. That is not necessary for us, right? So here it is a point of concurrency of internal angular bisectors. I am taking the length of the side is A, the length of the side AC will be B, the length of the side AB will be C, whose vertices will be given to you x1, y1, x2, y2, x3, y3. The vertices of a triangle will be given to you. At that time, how to find out the incenter of x, y is equal to A x1 plus B x2 plus C x3 divided by A plus B plus C. Similarly for y coordinate also. That is AY1 plus BY2 plus CY3 divided by A plus B plus C. A plus B plus C. And one point to be noted here, for an equilateral triangle, this is one of the most important concepts. For an equilateral triangle, all centers are same. All centers are equal. All centers are equal. And in center is denoted by I. All center means, sir, can be equal. Centroid is equal to orthocenter is equal to circumcenter is equal to in center. Yes, all the four centers are equal for an equilateral triangle. Sir, you have discussed internal angular bisectors. What about external angles? Yes, external angles are also possible. Even we people have studied in 9th standard lower classes. The external angle is equal to sum of the opposite internal angles. Suppose I have the triangle like this. We have the triangle. I can take here. If I'll extend this line, ABC, and here it is, your point D is there, and this angle is called an external angle or not. Suppose your line segment dividing into two equal parts, this line. So here for external, I mean X center, I am going to take the external part of your angles. External part of your angles. Right? But these four centers are important for us for competitive examinations. I'm repeating again, whenever he is asking any center, ortho center, circumcenter, or in center, your concept depends upon the properties. Especially for ortho center and circumcenter, he will ask for the questions related to the relation. This is one of the most important relation, or for the right angled triangle. Right angled triangle. The last center is there. I'll try to discuss that point. That is the X center. Point number 5. X center. X center. It is a point of concurrency of one internal angular bisector, one internal angular bisector, and two external angle bisectors. అదేంటి సార్ ఇంటర్నల్ యాంగిల్ అంటున్నారు మరి ఎక్స్టర్నల్ యాంగిల్ అంటున్నారు, ఆ ఇంటర్సెక్షన్ ఎలా జరుగుతుంది? జస్ట్ యూ కెన్ సీ హియర్ the figure will clear your doubts, right? Let's have the triangle ABC. Just you can extend it. Even you can extend it. It is a point of concurrency of two external angles. Here external angle B. Idi kada angle B, internal angle means this angle. So this angle internal. This is internal. This is internal. This is internal. External angles, sir. Here two external angles are there. This is also external angle. It is a point of concurrency of two external and one internal. These two are external angles. Another one, this is internal. So here we are taking from vertex A. So it is denoted by I1. Just I can write the formula for I1 only. So I1 is an internal. So I'll get minus AX1 plus BX2 plus CX3 divided by minus A plus B plus C is the formula. Similarly, Y coordinate minus AY1 BY2 plus CY3 divided by minus A minus B minus C. Right? Just we people have discussed 3 centers today. The problems related to this concept we'll try to discuss in the next class. Right? Hope you can understand today's topic centers. If you're having any doubts, you can. Otherwise, we'll close the session. I took just 2-3 minutes extra today because we need to complete this topic today. Yeah. Any doubts, please, regarding to this concept? Definitely, I'll try to send just within 5 minutes. I'll try to send the notes, no problem. If you're having any doubts, you can ask, please.
No, sir.
No,
No
sir.
doubt, sir. Swami.
Very good, guys. Very
No
good.
doubt,
Good night
sir.
to all of you. Very good. Good night to all of you. Hope you can understand today's concept. We'll meet you in the next class.
Thank you, sir.
Thank you, guys. Thank you, guys. Good night, all of you.
Thank
Thank you, sir.